Our journey begins in 1976, a year that marked a significant milestone in space exploration, when NASA's Viking 1 orbiter sent back an image that would forever change our perception of the red planet. This image, captured from the surface of Mars, sent shockwaves across the globe, igniting imaginations and sparking debates. There, in the Cydonia region, lay a mesa that bore an uncanny resemblance to a human face, complete with eyes, nose, and mouth. Scientists quickly stepped in to explain this phenomenon as pareidolia, the human tendency to perceive familiar patterns, such as faces, in random data. As technology advanced, higher resolution images of the Cydonia region were captured, revealing the so-called face to be nothing more than a natural mesa, shaped by eons of erosion and geological processes. Despite these scientific explanations, some people remained unconvinced. They claimed that NASA was covering up the truth, suggesting that the face was evidence of an ancient Martian civilization. The face on Mars phenomenon serves as a powerful example of how our deep-seated desire to find life beyond Earth can sometimes cloud our judgment and lead us to see what we want to see. Over the years, Mars exploration has continued to evolve, with each mission bringing us closer to understanding the true nature of our neighboring planet. From the early days of the Viking missions to the sophisticated rovers and orbiters of today, our quest to uncover the secrets of Mars remains as strong as ever. The face on Mars has also found its place in popular culture, inspiring countless works of art, literature, and even conspiracy theories, all fueled by our fascination with the unknown. As we look to the future, the idea of humans setting foot on Mars, and possibly even establishing colonies there, continues to captivate our collective imagination. The red planet, with its mysterious landscapes and potential for discovery, remains a beacon of hope and curiosity for scientists and dreamers alike. The face on Mars may have been debunked, but it stands as a testament to our enduring quest for knowledge and the boundless possibilities that lie beyond our world. Where there's water, there's potential for life. Despite its arid appearance, Mars shows signs of a wetter past. Martian rovers have discovered minerals that form in the presence of liquid water. In 2018, scientists announced a subsurface lake beneath the Martian South Polar ice cap. This discovery, if confirmed, could be a game-changer in the search for Martian life. The presence of water raises the possibility that life may have once existed on Mars. Earth's magnetic field protects us from harmful solar radiation. Mars, however, has a fossil magnetic field, remnants of a once stronger shield. Without its protective shield, Mars's atmosphere was stripped away by the solar wind. This process also played a role in the loss of Mars's surface water. The absence of a global magnetic field presents challenges for life on the surface. However, life could still exist underground, shielded from radiation. Methane, often associated with living organisms, has been detected in the Martian atmosphere. The Curiosity rover has detected seasonal spikes in methane levels. This has led to speculation that the methane could be coming from subsurface reservoirs. While biological activity is one possibility, geological processes are also considered. The methane mystery highlights how much we still don't know about Mars. We are still in the early stages of exploring our celestial neighbor. Mars has two small, irregularly shaped moons, Phobos and Deimos. These moons are fascinating not only because of their unique shapes, but also due to their mysterious origins and intriguing characteristics. Unlike our moon, which is spherical, Phobos and Deimos resemble lumpy, misshapen asteroids. Their surfaces are covered in craters and grooves, telling a story of countless impacts over billions of years. Phobos orbits Mars at an incredibly close distance, rising and setting multiple times each Martian day. In fact, Phobos is so close to Mars that it completes an orbit in just about 7.65 hours. This rapid orbit means that Phobos rises in the west and sets in the east, opposite to what we experience on Earth. Its proximity to Mars also means that it is gradually spiraling inward, getting closer to the planet with each passing year. Its most striking feature is a massive impact crater named Stickney. Stickney crater is about 9 kilometers in diameter, nearly half the width of Phobos itself. This enormous crater was likely formed by a significant impact event, and its formation may have caused fractures and grooves that are visible across the Moon's surface. The crater is named after Chloe Angeline Stickney Hall, the wife of Phobos' discoverer, Asaph Hall. Deimos is much smaller and orbits at a greater distance from Mars. Unlike Phobos, Deimos takes about 30.3 hours to complete one orbit around Mars. This means it rises in the east and sets in the west, similar to our Moon. Deimos' surface is smoother compared to Phobos, with fewer large craters, suggesting it has experienced less impact activity. Its smaller size and more distant orbit make it less affected by Mars's gravitational forces. Both moons are tidally locked to Mars, always showing the same face to the planet. This tidal locking means that the same side of each moon is always facing Mars, similar to how our Moon always shows the same face to Earth. This phenomenon occurs because the gravitational forces between Mars and its moons have synchronized their rotation periods with their orbital periods. One theory suggests they are captured asteroids. This theory posits that Phobos and Deimos were once part of the asteroid belt between Mars and Jupiter. At some point, they were gravitationally captured by Mars, becoming its moons. Their irregular shapes and cratered surfaces support this idea, as they resemble many of the asteroids found in the asteroid belt. Another theory proposes they formed from debris after a massive impact on Mars. According to this hypothesis, a colossal impact on Mars ejected a significant amount of debris into orbit around the planet. Over time, this debris coalesced to form Phobos and Deimos. This theory is supported by the Moon's composition, which is similar to that of Mars' crust. Phobos is on a collision course with Mars, potentially creating a ring system or a massive impact crater. As Phobos continues to spiral inward, it is expected to either crash into Mars or break apart due to tidal forces. If it breaks apart, the debris could form a ring around Mars, similar to the rings of Saturn. This event is predicted to occur in about 30 to 50 million years, making it a fascinating future scenario for scientists to study. Mars' surface is a testament to a bygone era when liquid water flowed freely. Valles Marineris, a colossal canyon system, stretches over 4,000 kilometers across the Martian equator. Deltas like those in Jezero Crater provide strong evidence of past water flow. These features tell us Mars was once much warmer and wetter. Understanding the history of water on Mars is crucial to unraveling the planet's past. It also helps us understand its potential for harboring life. Mars has a reputation as a cosmic Bermuda Triangle, where missions fail. The reality is that Mars exploration is inherently challenging. The vast distances, harsh environment, and nature of space travel contribute to the high-risk nature of these missions. Despite the challenges, our pursuit of Mars continues. Each mission provides valuable data and lessons learned. The so-called Mars curse is a testament to the ingenuity and resilience of scientists and engineers. Mars dust storms can engulf the entire planet in a reddish haze. These storms, driven by intense solar heating, can last for months. The dust can play havoc with robotic explorers, coating solar panels and reducing visibility. In 2018, a planet-encircling dust storm ended the Opportunity rover's mission. Dust storms play a crucial role in shaping the Martian climate. Understanding these storms is essential for predicting future climate change on Mars. Scattered across Mars are formations known as hollowed-out mounds or inverted relief. One theory suggests they were once buried beneath layers of sediment. Wind erosion gradually removed the surrounding material, leaving behind the more resistant core. Another theory proposes they are remnants of ancient hydrothermal vents. These formations offer a glimpse into Mars' complex geological history. They remind us that there are still many mysteries to be solved on this enigmatic world. The ultimate question driving our exploration of Mars is whether life ever existed there. This quest has captivated scientists and dreamers alike for generations. Mars, with its mysterious red surface and intriguing geological features, has long been a focal point in our search for extraterrestrial life. The barren landscapes and ancient riverbeds suggest that Mars once had conditions that could have supported life. The evidence we've gathered so far paints a tantalizing picture, but definitive proof remains elusive. We've discovered signs of ancient water flows and certain minerals that form in the presence of water. These findings hint at a potentially habitable past. However, the search for conclusive evidence of life, past or present, continues to challenge us. Each mission to Mars brings us closer to understanding the planet's history and its potential to harbor life. The search for life involves looking for biosignatures, such as organic molecules or isotopic ratios. These biosignatures are chemical indicators that could suggest the presence of life. Scientists meticulously analyze soil samples and atmospheric data, searching for these elusive signs. The discovery of even the smallest organic molecule could revolutionize our understanding of life beyond Earth. Future missions will carry sophisticated instruments capable of detecting these biosignatures. These advanced tools will allow us to probe deeper into the Martian surface and atmosphere than ever before. Engineers and scientists are working tirelessly to design and build these instruments, ensuring they can withstand the harsh conditions of Mars. The next generation of rovers and landers will be equipped with cutting-edge technology, bringing us closer to answering the age-old question of whether we are alone in the universe. These missions hold the potential to finally answer the question of whether we are alone in the universe. The launch of each new mission is a moment of excitement and anticipation. As spacecraft journey through the vast expanse of space, they carry with them the hopes and dreams of humanity. The landing sequence, a critical and nerve-wracking phase, marks the beginning of a new chapter in our exploration of Mars. The search for life on Mars is a journey driven by our desire to understand our place in the cosmos. It is a quest that pushes the boundaries of science and technology, inspiring generations to look up at the stars and wonder. As we continue to explore Mars, we are not just searching for life. We are seeking to understand the fundamental nature of life itself. This journey, filled with challenges and discoveries, brings us closer to unraveling the mysteries of the universe and our own existence. If you enjoyed this video, check out these 10 black hole facts that you won't believe.